Question number 28. It reads, a ball projected horizontally from a large inclined plane collides successively with the plane. Coefficient of friction between the plane and the ball during these collisions is mu. What should be the inclination of the plane and the coefficient of restitution for the collisions so that between every two successive bounces, the ball follows identical trajectories? So the condition is the ball should go with the identical trajectories. Now let's consider this is inclined plane which is long enough, and this is angle of inclination theta which we need to find out. And a ball is being thrown horizontally with velocity u. So if this is horizontal, so this angle is going to be theta, same angle. We can make component perpendicular to the inclined plane u sine theta, along the inclined plane u cos theta. We know the gravity which is vertically downside can have two components, one along the inclined plane, another perpendicular to the inclined plane. This is g sine theta, this is g cos theta, you are well aware of. And let's say this ball goes like this per a projectile and hits for the first time, then it will be hitting for the second time, and so on. And we want all the trajectories should be identical. Let's consider just before this first collision, the velocity components of this ball is v1 along the inclined plane and v2 perpendicular to the inclined plane. Now think, if just after this collision the ball attains the same velocity as it had earlier, the time of projection, so the situation that is going to follow this will be same as it had gone through earlier. That means that this trajectory will be identical to the next trajectory. That means just after this collision, velocity must become horizontal as u, or you can think of it must have these two components. So that's what written over here. Now, using that condition, we can apply the formula of coefficient of restitution, which says velocity of separation divided by velocity of approach. Now, for this collision, the v2 is the velocity of approach, and then after it's going to bounce back just like this. So this will be the velocity of separation, of course, along the line of impact. So line of impact is perpendicular to the inclined plane. Hence, we are looking for the velocity component, which is perpendicular to the inclined plane. So this will be behaving like, which is going to come basically over here in this point as velocity of separation, and this is going to be velocity of approach. So E is velocity of separation divided by velocity of approach. So this is E expression. Now we can find out this v2 velocity and v1 velocity by using the kinematics. To get this v2, we can apply this perpendicular to the inclined plane motion, and where the gravity is in this direction, g cos theta, initial velocity is this is the final velocity, and let's say capital T is the time which it took to go from here to here. This time is air time, or we call it as the time of flight, and the time of flight is written as 2 times perpendicular component of velocity, which is u sine theta, divided by perpendicular component of acceleration, which is g cos theta. Perpendicular means perpendicular to the inclined plane. So this is the time of flight. That means this v2 velocity is perpendicular to the inclined plane after this time starting from the initial. So we can use v is equal to u plus at formula. V is I'm writing as a minus v2. I'm considering this upward direction as a positive, so v2 is negative. U sine theta is positive, minus acceleration is g cos theta, and t is there. Now we can put the value of t. Then you'll find this gt cos theta altogether is 2u sine theta. So this entire is 2u sine theta. So I have written over here. From here we are able to find this v2 is equal to u sine theta. Now this v2 came out to be positive. That means it is in the direction that we have taken. So v2 is u sine theta. Now we can substitute this v2 on this expression. So E becomes u sine theta divided by v2, which is again u sine theta. So u sine theta divided by u sine theta is equal to 1. That means coefficient of restitution is 1, meaning the collision must be elastic in nature. So second half part of this question is completed. Coefficient of restitution for the collision. So all collisions which are going to take place successively must be elastic in nature, in order to ensure identical trajectories, of course. Now we need to think about angle of inclination. So we need to work on this motion which is along the inclined plane. along with the collision story. So let's consider this collision occurred for delta t time. Any collision. So I'm just looking on the first collision. So we can write the impulse equation. Impulse equation will say impulse is equal to change in momentum. And you'll find when it strikes, it had this velocity, so it will try to slide downside. So friction will be acting upward direction. Upward direction. So we can write it as uh, friction into delta t. That's impulse. Now, in this case, I have taken this downward direction as a positive. It's your choice, whichever you take as a positive. So the friction is upward, which is going to be written as a negative. But whatever we take it, we need to stick to it, right? So it's like minus f delta t. F is mu n, and final momentum minus initial momentum. Final momentum will have this velocity along this direction. So it's going to be mu cos theta positive minus initial momentum. Initial momentum is this, because when we are saying final, that means just after the collision, right? And this v1 is initial. Just after collision, it will acquire the velocity same as this. That's why I wrote this minus mv1, of course. And then this can be simplified. Now, to simplify this, we need to know what this normal reaction is going to be. So we can have impulse equation in the perpendicular direction as well. So in perpendicular direction, you will get a normal reaction acting in the upward direction. So n delta t, that will be equal to change in momentum in the upward perpendicular direction. Final momentum will be having a velocity upward equal to this. So that will be mu sin theta. Initial velocity just before the collision basically is v2, which is downside. So minus mv2. We need to subtract the 2. v2 is basically u sin theta. So it turned out that n delta t is equal to 2 mu sin theta. Now here n delta t is involved. We can substitute over here. So it turned out to be minus mu into 2 mu sin theta is equal to this number, which is mu cos theta minus mv1. M can be cancelled out. V1 can be calculated, which turn out to be mu cos theta plus 2 times mu u sin theta. We can take u outside. So it's a bracket, within bracket it is cos theta plus 2 mu sin theta. That's a V1. And this V1 we have calculated by using the impulse equation. We have another way to do so, or to find it out. The another way is the kinematics. We can use the kinematic equation in this direction, because this g sin theta is a constant acceleration. So, and this is the time after which this velocity was acquired in this projector, right? So we can write this v1 is equal to u plus at. U is u cos theta plus a is g sin theta into t. All is downward direction, so we have taken downward direction as a positive. That's why every number is being written as a positive. Now u cos theta as such, and this t can be written from here. So gt is equal to 2u sin theta by cos theta. So that is 2u sin theta by cos theta. There was sin theta as well, so multiplying by sin theta. You can take u as a common, so within bracket it comes out to be cos theta plus 2 times sin theta by cos theta is tan theta into sin theta. Now this is expression of v1. This is also expression of the same v1. Now since these two expressions are identical, or has to be the same, so we will say that let's equate them. So u is common, cos theta is same, 2 is same, sin theta is same, so mu must be equal to tan theta. From here we concluded tan theta must be mu. Therefore theta must be tan inverse mu. So angle of inclination must be tan inverse mu, and coefficient of restitution must be 1. That will ensure that successive bounces will give us the identical trajectories. Hence, these are our final responses. Answer. Thank you.